Welcome once again to my YouTube channel. So today we are taking a topic in physics, the resultant vector. Firstly, we define vector as any quantity that has magnitude and the direction. Any quantity that can be specified, any quantity that can be directed, any quantity that can be given direction. So in that very case, vector is a quantity which has both magnitude and as well as direction. Now, on the part of resultant vector, as a type of vector, we see it as the sum of two or more vectors taken together. When you have two vectors or more and you are asked to find the resultant vector, they are simply demanding that you should sum it up in order to get a single vector. So, single vector you obtained is what is termed resultant vector. So, resultant vector can be defined as a single vector that has magnitude and the direction as two or more vectors acting together. I repeat, resultant vector is a single vector that has magnitude and the direction as two or more vectors acting together. Now, we are going to use force as a case because we know that force is a vector. We have other quantities that are vectors, such as velocity, acceleration. All these quantities can be specified, can be directed, can be explained with respect to direction. Now, we are going to learn how to obtain resultant vectors. If two or more vectors are given, then how are you going to compound the vector in order to get a single vector? When you compound two or more vectors, you are obtaining a single vector known as what? Resultant vector. We have many ways or methods which can be used depending on how the vectors are arranged. We have a method known as parallelogram method. We have another method known as triangular method. We have another method known as component method. And finally, we have graphical method. Now, any of these methods could be used. Now, let's start with parallelogram law. That's the parallelogram method of resolving vectors. The parallelogram method of obtaining resultant vector. Now, we are going to look into the law first. Now, based on this parallelogram method, if you have two vectors, let's say we have a vector, like I said, we are taking force as a replica. Now we have a force. Now this is a vector because we normally use directed line to represent vector. Then we have another vector. We have another vector, F2. Now these two vectors are inclined at angle theta. Now if you are asked to find the resultant vector, which is a single vector that will represent these two vectors both in magnitude and the direction. Now, using the parallelogram method implies that this ought to be arranged in a parallelogram form because we see parallelogram as four-sided plane figure, which opposite sides are equal and parallel. So in this very case, if we are to resolve this using parallelogram law, then we have to put it up in a parallelogram form. So we have this now. Now, in this very case, we have another line now, which is this. And this line will be equal and parallel, also in the same direction. We have this as F2. Then again, we have this very one in the same direction with this F2 and also parallel. We have it as F1. Now, as we have formed the parallelogram, now we have a line drawn from this point of intersection of two vectors. Then we take this very line to meet this point. Now, if we can get the length of this in that same direction, that gives what? The resultant what? Vector. And the direction of it could be obtained based on the force, the one that is greater in magnitude. If F2 is greater in magnitude, then the direction of this resultant will now be obtained in this very point we have here as the direction. So, what does parallelogram law state? Now we have the parallelogram law. Now, the parallelogram law states that when two vectors acting at a point are represented by adjacent sides of a parallelogram, the resultant is represented by a diagonal line drawn from the point of action of two vectors. So in this case, we have two vectors. Now we represent these two vectors by adjacent sides of a parallelogram. Okay? Now, in order to get the resultant, we draw a diagonal line from the point of action of two forces. So this diagonal line drawn from this very point represents the resultant, both in magnitude and in direction. Look at the direction here. That same direction, then the length shows the what? The magnitude. Now, if we're to obtain the resultant, we can employ this theory. Look at, here is angle theta, which means angle here will still be what? The same. The opposite angles of a parallelogram are equal. Now, if here is theta and here automatically becomes theta, then in order to get the angle here, which will also be equal to angle here, then it will now be 180 minus theta. Okay? How? Let's say we have this as a parallelogram. Then this very side is equal to this side. Okay? Now, if here is F2, here will be F2, right? Then coming to this very side, if here is F1, here will also be what? F1. Now, let's say that the angle here is theta, and the angle here will also be theta. Okay? Then, what will be the angle here? If here is x, here will still be what? X. Now, we are looking for the value of theta. You remember sum of angle in a quad, we have it to be 360 degrees, right? So, at this point, in order to get the value of x, you remember sum of angle in a quad is equal to 360, right? So in that case, we have 2 theta, because here we have 2 theta, right? And the 2x. If you sum it, it will give you what? 360 degrees, right? It's 360 because sum of angle in a quad is equal to 360. So in that case, divide both sides by 2. Then we are going to have theta plus x is equal to 180 degrees, right? Now we are looking for the value of x. If you make x the subject of the formula, we are getting 180 minus theta. So that's how we got this very angle. So in this very case, we can take one of the triangle because we know the diagonal has splitted this parallelogram into two triangles. So if we take one of these triangle now, we are going to have this. Here is the resultant. Okay. Then we have F2. Here is F2. Then here is F1. So we have F1. Now here is the direction. While the angle here is what? Is 180 minus theta. By cosine rule, we have R squared equal to F1 squared plus F2 squared minus 2F1 F2, then cosine of that very angle, which is 180 minus theta. So at this point, the resultant vector now becomes the square root of F1 squared, F2 squared, minus 2F1, F2, then cosine of 180 minus theta. That gives the resultant. Okay, now if you now want to obtain the direction, you can employ sine rule. Now remember what I told you. The direction of this resultant with respect to F2 implies that F2 is either greater than F1 or F2 is equal to F1. It is the larger force that will determine the direction. Okay? So in that case, we have the direction here. Now, if we are to employ sine rule in order to get direction, then we are going to have the sine of the alpha here all over the side of it, which is F1, equal to, already we've got the angle here. So sine of 180 minus theta all over the side of it, which is the resultant. So if we simplify this, in order to get alpha, cross multiply, F1 will come over here. We have the sine of alpha equal to F1 sine 180 minus theta all over resultant. Now, if you should make alpha the subject, you now have sine inverse F1 sine 180 minus theta all over R. That gives you the what? The direction. So this one is the magnitude, okay? While alpha is the direction. Now let's apply it in practice. So we have question on the board. The question reads, two forces F1 and F2 act on a particle. F1 has a magnitude of 5 Newton and in the direction of 30 degrees, and F2 has a magnitude of 8 Newton and in the direction of 90 degrees. Find the magnitude and direction of the resultant vector. Now, in order to simplify this using parallelogram method, we have to represent the force first. Now, two forces F1 and F2 act on a particle. Now, F1 has a magnitude of 5 Newton in the direction of 30 degrees. Then 30 degrees, we have this. We have this as a component, X and the Y axis. Now, if here is the origin, we have angle 30 degrees starting from the north. Here is the north. So it will have 30 degrees. So the very first vector, which is 5 Newton, is seen here. Okay. Then that 5 Newton is the what? Is the F1. So F1 is 5 Newton. Okay. Then F2 has a magnitude of 8 Newton and in the direction of 90 degrees. Now 90 degrees from here should be here. From here to here is what? Is 90 degrees. Okay. Now the magnitude of it is 8 Newton. That should be F2. Are we there? So we've represented the vectors using a diagram. Now, in order to resolve this, let's look into the angle in between F1 and F2. Then from this, if here is 30 degrees, probably here must be 60 degrees because here is right angle. Okay? So in that case, you now say that what we have now is this. Here is 5 Newton, right? Then we have 8 Newton separated by angle of 60 degrees. So as we're about to use parallelogram method, we have to resolve this in a parallelogram form. So in that very case, here is what? 8 Newton. Then here is also 5 Newton. Okay? Now we draw a resultant. Here is a resultant. Now, like I said, if angle here is 60 degrees, the angle here must be 180 minus what? 60 degrees. Okay? Now, we've got that very what? Right angle triangle here. We have two triangles here now. So, in order to find the resultant vector, okay? So, we have the resultant vector, which will now be square root. We have two vectors here, 8 squared plus 5 squared minus 2 times 8 times 5. Then cosine of 180 minus 60. Okay? That will give us the magnitude. So let's simplify this. The very first one we have 8 squared. So the resultant becomes square root. The 8 squared will give 64. Then the 5 squared will give 25. Minus 2 times 8 times 5. 2 times 8 times 5. We are going to have 80. Then cosine of 180 minus 60, which will give 120. So at this point, we sum 64 and the 25. Then we have the resultant as the square root. We have 89 minus 80 cos 120. Okay? Now, this cos 120 is the same thing as minus cos 60 degrees. As in, you can bring it back to first quadrant. Okay? So, if you do that, we have the resultant to be 89 minus 80 cos 120 is the same thing as cos minus cos 60 degrees. So here we have R equal to 89. If you open the bracket, we have plus 80 cos 60 degrees. Although you can still work it direct to get your answer. You can just work on 80 cos 120. It's still the same thing. So we have 80 cos 60. 80 cos 60 will give us 40. So we have R equal to 89 plus 40. So if we add 89 to 40, we get the resultant as the square root of 129. So what's the value of square root of 129? We are going to get 11.36 Newton, and that gives the magnitude. So the magnitude is 11.36. Now, in order to get the direction, then the direction will now be measured with respect to the one with higher magnitude. We have 5 Newton. No, it can't because it's a smaller magnitude. We have 8 Newton. So the direction will be here, right? So in order to get the direction, here is right angle now. So we have the triangle. So here is direction. Here is the resultant, which we've got to be 11.36 Newton. Then here is 5 Newton. Then we have 8 Newton, right? Using sine rule now, we have sine of the alpha all over each side, which is 5 Newton, is equal to, we already know the angle here, which is 180 minus 60. Here is 120. Okay? So sine of this angle all over each side, then equal to sine of this angle all over this side. That is sine 120 all over the side, 11.36. So we now need to obtain the value of alpha. So sine alpha will now be 5. We multiply this, 5 sine 120. Then all over 11.36. Now, if you simplify this, 5 sine 120 divided by 11.36, then we are going to have 0.3812. Okay? Then we take the sine inverse. If this sign should cross equality sign, we have sine inverse of this. So what will be the sine inverse? So the angle now becomes 22.4 degrees. That gives the direction. So here now is the direction, right? Now we've got the magnitude and the direction. Okay? So I can just put it in this way. The resultant vector is 11.36 Newton in the direction of 22.4 degrees. So that's the answer. So let's quickly move into triangular method. The triangular law of vectors states that when two vectors are represented by two sides of a triangle taken in order, the third side taken in opposite direction represents the magnitude and the direction of the resultant vector. Take for example, I have a triangle. Now, if this very triangle, we have two. So we have this one moving in the same direction with this. They are moving in the same direction. Now, if I have this as the two vectors, now instead of this third one to move in that same direction, its direction will be reversed. Okay? So that shows that this one is a resultant of these two vectors. So the resultant vector of a triangle, as in if you are using a triangular method, the two vectors will move orderly, will move in the same direction. But the resultant, which will now be the third side of the triangle, its direction will be reversed. So that gives what? The triangular method. Okay, now the triangular method of two vectors. For example, if we want to resolve it, you can just split it and take that vectors one after the other. Okay, in order to form a triangle. Okay, let's just say that we have a vector, two vectors, like the very first one we did. Let's say we have two vectors inclined at an angle. Let's say we have here F1, here is what? F2. Inclined or separated by an angle. If I'm to resolve this using triangular method, I'm going to take them one after the other. I might start with this. Then I have this F1. Now here is F1. Then look at the F2. In that same direction, we have what? F2. Now, in order to get the resultant, you now start again from the initial position here, you join it to the ending. That gives what? The resultant vector. Now, in order to get this very direction, this angle, the angle is found between F1 and F2. And here is F1, here is F2. So you can extend this. You see F1, F2. So the angle is seen here. So in order to bring this angle inside this triangle, you now consider a straight line where this theta plus the angle here will give you angle on a straight line, which is 180. That means here the angle will now be 180 minus theta. And that gives you what? A triangle. So with this, in order to find this very resultant, you see that you've got that triangle, just like parallelogram. So you can also use cosine rule. Then you have R to be square root. We have F1 squared, F2 squared minus 2 F1 F2. Then cosine of that same angle inside there. So you see is the same thing with that of parallelogram with respect to the magnitude. So the direction can as well be obtained using sine rule, which is sine. Okay, let's get the direction. Like I normally tell you, F1 and F2 are two vectors. The one that will determine the direction is that very one with the higher magnitude. So this is the resultant. Let's say that F1 is the one with higher magnitude. Then I'm going to take the direction of this resultant from F1. So in that case, you have sine alpha all over the opposite, which is F2, equal to, we have this very angle already, sine 180 minus theta, all over the side of it, which is resultant. So you simplify it as the way we did the other, you still get what? The direction. Now let's have a question on it. We have a question on the board. Now we are going to use triangular method to simplify it. The question reads, an object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of the two forces if the two forces act at an angle of 30 degrees to each other. Then 2, the two forces act at an angle of 120 to each other. So I'm going to solve one, then you try the second exercise. Now, using the triangular method, solution, an object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of two forces. If two forces act at an angle of 30 degrees, so we have two forces, F1, we have it as 5 Newton, maybe F2, we have it as 12 Newton. Then the angle of separation is 30 degrees. So in this very case, we can just put up two forces here. Here is 30 degrees. The shorter force there is 5 Newton, right? So we can have 5 Newton. The longer one, we have 12 Newton. So we have the two forces here. Now, in order to simplify this using triangular method, then I can pick any force at a time. Maybe I have 5 Newton. Here is 5 Newton. Then the longer force there is 12 Newton. So 12 Newton is greater than 5 Newton. So we have 12 Newton, 12 Newton. Then the angle between 12 Newton and the 5 Newton, look at, the angle is here, which is 30 degrees. Okay? So in order to get the resultant, I have to start from the beginning here, get the resultant. So in that case, what's the resultant force? Now, in order to have the angle inside the triangle, I compare this very one, hence angle on a straight line. Here will now be what? 30 minus it from 180. Here will now be 150 degrees because sum of angle in a straight line is 180. Then we've got this very triangle. Now with this very triangle, we now solve the resultant. So the resultant will now be square root. We have two forces in question. 5 squared plus 12 squared minus 2 times the product of two vectors. Then cosine of the angle inside here, we have 150 degrees. So the resultant now becomes square root of 5 squared now is 25. 12 squared is 144 minus 2 times 5 is 10 times 12 is 120, then cos 150. Okay? So we simplify this now. So at this point, 25 plus 144, 25 plus 144, we have 169. So here we have 169 minus 120. Now cos 150 is the same thing as minus cos 30. Okay? As in order to bring it to the first quadrant. So here we have r equal to minus 120 times minus cos 30 will give you plus, because minus times minus is plus, right? So we now have resultant 169 plus 120 cos 30 degrees. Now, we simplify this now. 120 cos 30, 120 cos 30, we are going to have 169 plus 103.92 or 92. Okay, so we add it together. 169 plus 103.92. So we have resultant 272.92. So get the square root of it. The square root will now give the resultant 16.52 Newton. Now we've got the resultant as 16.5 Newton. Now, in order to get the direction, now let's check the magnitude, the one with higher magnitude. There is the one. Okay? 12 Newton is the one with the higher magnitude. So it is that very one that will determine the direction. So in that case, the angle between that 12 Newton and the resultant, we have the direction here. Okay? So the direction will now be sine of this angle all over the side of it, which is 5 Newton, is equal to, we have another angle which is 150, sine 150 all over the side. The side now is the resultant, and we've got the value of the resultant. The value of the resultant now is 6.52 Newton, right? So we have here 6.52 Newton. So in order to get the alpha, 5 will times this. So we have sine alpha equal to 5 sine 150 all over 16.52. So if you punch 5 sine 150 divided by 16.52, then we have sine alpha 0.1513. So if sine should cross equality sign, we have sine inverse of 0.153. So what's the sine inverse? The sine inverse of 0.1513. So it's going to give us 8.7 degrees. So that gives the direction. So in that case, we have the force, which is the resultant force. The magnitude is 6.52 Newton, while the direction is 8.7. So we have it as the answer. So next class, we are going to look into component method. See you on our next class. Please do subscribe, share, and turn on notification for others to learn as well.